Hello, everybody, and welcome to this episode of the Ampere Developer Impact. I'm joined today by Craig Kerstiens from Crunchy Data, Chief Product Officer, I should say, for Crunchy Data. Craig, thank you for joining me.
Yeah, happy to be here.
And so you've been using some Ampere hardware for a little while, but before we get into talking about what you do with Ampere, a lot of people probably haven't heard of Crunchy Data. And now I know you as a Postgres company. Can you give me a little overview of your product portfolio and what you add on top of Postgres to kind of differentiate your products to the market?
Sure. Yeah. I mean, I think thinking about that, if there's anything, it's kind of everything Postgres, right? As a Postgres company is a great simple summary, right? One, two word. I mean, Dave, you and I have been in the open source world for a very, very long time. Um, Crunchy actually started kind of focused on the enterprise, and I'll get a little bit into some of the products pretty quickly. But really, when you look at the enterprise, like even today, open source is still generally newer, right? Especially on some things like data. And so when the enterprises came to us, they looked at, they've heard about this Postgres thing. Maybe were running DB2 or Oracle, traditional legacy kind of enterprise databases, wanted to get into the Postgres space and world. Now, Postgres is a great, wonderful open source database, but when you think about what it takes to run a production database in production, like, you've got disaster recovery, you've got monitoring, you've got HA, you've got connection scaling, you've got all of these things that, as an enterprise, what would they do? They'd say, all right, we're going to evaluate these 6 tools for disaster recovery and these 5 tools for high availability. And they're going to be doing kind of valuations and bake-offs for 6 months, 12 months, 18 months. Then by the time they start to put these pieces together, everything's changed out from under them. And so where we started was a curated distribution of Postgres, very similar to the Red Hat model, right? Where, hey, I want to run Linux, but Red Hat Linux, I've got security patches, I've got trusted supply chain, I know what's in there, I know upgrades are tested, all of that. Very similar to, hey, if you're using Red Hat for Linux or other similar products, we give you that for Postgres on the enterprise side. That's really where we started. More recently, I came on board a number of years back to help build out our cloud managed service. We've got a fully managed service that's available multi-cloud, so on AWS, Azure, and GCP, that gives that same production level experience of simple provisioning, backups, monitoring, HA, all of that with full Postgres super user. And the fact that it's multi-cloud means you're not locked in. So you can easily migrate between AWS, Azure, GCP as you see fit. Really just kind of a best-in-class cloud service. Most recently, back in November, we launched a data warehouse, our take on a modern data warehouse. So Postgres kind of isn't new to data warehousing. If you look, there's a lot of long legacy options there, things like Redshift and Netezza and Greenplum. We took a modern approach to that, building on open table formats like Iceberg that you can kind of plug into other things like Spark and DBT seamlessly. And it's seamlessly integrated that to Postgres. So you've got the Postgres that you know and love now as a data warehouse experience. And that's our most recent product in the space.
Brilliant. Well, I know you've been working with Ampere for a while, with Ampere hardware, I should say, to add Arm64 support for your product portfolio. Can you talk a little bit about the genesis of that? What was the impulse for doing so? I mean, adding a new architecture, I imagine, could have been some work. And what was the experience like?
Yeah. And so, the big reason was really that balance of performance and cost saving side, right? We've seen that really clearly, and it was heavily customer driven. We had several customers that had seen when they'd rolled out some of their Kubernetes workloads to Arm64, some great performance on the application side, and really pushed us to do the same on the database side. A large part of what we do and why you trust Crunchy is around supply chain, especially in that on-premises, self-managed environment, right? We have some very high trust, high security companies that want to know that we built it on our own hardware, and that's a big part of why you trust us, right? New patches and security releases come out for underlying dependencies in Postgres. We package that on day one of the release and have packages available for our customers. And we built that on our own hardware. And so a large part of working with Ampere was we couldn't just grab an instance from the cloud and build because of that trusted supply chain, right? We wanted that hardware. We needed that hardware to manage ourselves. From an Ampere perspective, like we were looking to do this, I would say kind of around peak pandemic, and supply chain was a mess. We talked to a lot of vendors to try to actually acquire hardware, and we were getting answers that were, hey, maybe we can get you something at 6 to 12 months, and that was a maybe. Working with you all, I would truly say, was wonderful experience. You know, what do you need? How many of them? How quick can we get it to you? It was a wonderful experience that we did not see with any other vendor. So first off, thank you for that.
Well, thank you.
Um, from a, well, what did we have to change perspective? If you asked me 2 years ago, my answer probably would have been a lot different. Like Postgres is very robust, big ecosystem around it, has been built for a ton of different architectures, right? So Postgres itself, not too many changes to vanilla Postgres, worked pretty well out of the box just from could we get it to build. Now, we run with more than just Postgres. There's a lot of components, and there was a lot of upstream packages that we kind of had to play a little bit of a waiting game or go fully package ourselves to work with ARM64. Now, today, I think a lot of that is a solved problem. But 2 years ago, there was a little bit of working with, other teams and packaging teams to say, they had hard coded in, nope, error. This isn't x86, right? And sometimes we were like, well, can you just try it? Like, please? They're like, well, we don't know if it's going to work. Like, well, can you try it and we'll test it and see if it works, right? There were a lot of just assumed things from software that had been out there for a long time. Um,
And this
we're
is typically
very,
open source dependencies, or
yeah, open source dependencies. I mean, one that I recall, there were a lot of Python dependencies that we support on our cloud managed service. And so we support PL Python, which is rare for a managed service. So you can run Python code from inside your database. So if you don't like writing procedural SQL, you can write PL Python. One really cool thing that you can do with that is we embedded NumPy and SciPy and Pandas. So you can do like, scientific numeric computing, you know, ML type stuff directly on your database as it sits.
well,
Those were not built and packaged for, ARM64 at first. I don't know what the changes were, but it was a kind of waiting pattern of like, well, there's 20 different open source packages that need to be built and supported for it. And well, we got 18, we're still waiting for the two. So there was definitely some long tail there. Like we needed all the packages for a managed service to be able to support it. For our on premises customers, not all of them used all the packages and they could pull what they needed. So we were able to get that support a little bit faster there. Um, Now I would say if you're coming to it fresh, right? Like in part, we've kind of helped blaze some of that trail of a lot of those packages. And I think broader open source communities now are consistently building on ARM64. You see that like a lot of this was, some of it was small, just hard coded. This is hard coded for x86. We don't have to change anything. We've got a build flag that says this is what we build on. And if it's not that, it doesn't build. Some of that was deeper changes in upstream open source things. you know, that was 2 years ago when we started this journey, or almost 2.5 now. I think today it's a much smoother path. So if someone's coming to it fresh and new, I wouldn't have those same warning flags, if that makes sense.
okay, absolutely. How did you have to evolve your CI infrastructure to add a new architecture? Was it just once you got the Ampere hardware? Was it fairly straightforward? What do you use for CI?
So we run a lot of internal Jenkins for CI and that sort of thing. It was another kind of build target for us. It was
Okay.
some effort, but we already build for different versions of kind of Red Hat Linux and UBI and other things that it was some effort. But once we had the hardware, it was for us because we already did build for so many diverse ones. We've built for Solaris before, not the most fun thing, right? So it was a pretty easy slot in given some of the journeys we've had before.
Okay. And in terms of packaging, right now, as an operator, right, the crunchy data operator, you're packaging containers.
Yep.
Any issues packaging Postgres as kind of a multi-arch container? Like, how do you deliver it? Do you do separate packages for ARM64 and x86?
We,
That you or do you do a single multi-arch manifest as well, and in addition to building those
we do
architectures?
single container builds there, right? So we have a
Okay.
build container that's just for that. It's a Docker container ready to go for Kubernetes, right? That you could
Right.
just go and ship off. So we do have separate ones, kind of extending on, right? What did we change or modify, right? We're running Postgres. We actually didn't have to modify a ton there.
Hmm.
There are some things that years ago we modified for Postgres, and we actually worked to upstream one core change to Kubernetes around supporting huge pages within Linux and within, I believe it was OpenShift specifically, didn't support huge pages. That's a massive win when running Postgres in any form for us. And
Okay.
so we want to run with huge pages. My apologies. We didn't go and benchmark with, ARM64 with huge pages on or off because we'd already started to flip that on for x86, that it was a big win. It may be a bigger win on ARM64. So that's one of those things that if you are running, I do recommend investigating the huge pages support. It was great for us. It's a big win for our customers. It was one of those kind of like a free performance boost, right? Free
Okay.
performance is always wonderful. Beyond that, not a lot of ton of specific things that we had to tune. We kind of leave some of that because Postgres is run in so many different environments, whether you're more of a transactional workload or analytical workload, that customers can come in into, shared buffers and that sort of thing themselves on their database.
Okay. So you haven't, for example, tried on ARM64 with 64K kernel page size rather than 4K kernel page size to see if that, in addition to huge pages, offers an additional benefit.
We have not. Some of our customers may, because some of them go very deep on that.
Okay.
For us, we package it up and kind of leave some of that to our customers that want to go deeper. So it's not a thing that we kind of ship by a default and benchmarked in depth yet.
Got it. So you talked about how this is customer driven. You talked about how customers saw cost savings on other workloads and wanted to see similar cost savings on Postgres on running Crunchy. Can you give me some idea of, since you've released the packages for ARM64, what has the reaction been with your customers? Do you have any customers running on-prem on Ampere hardware, for example?
Yeah, I don't know if specifically on Ampere hardware. I do know they're running on ARM64, kind of self-managing that. I have to go check the exact hardware. Um, Postgres and workloads are, people are like, hey, what's the performance boost of this or that? It's so hard to say because databases, what's the exact data pattern and workload and query access pattern and that sort of thing for me to say, hey, definitively you can get this. I can tell you we have had customers that have relayed to us they've seen a 10 to 20% performance boost while running on a cost savings on their hardware of up to 30%.
Wow.
So definitely some real savings there. That may be the high end. I can't say if that's the high end or low end because a lot of this is hard to measure and it depends on, hey, customers, how well are they managing and test marking and benchmarking their own workloads.
Okay.
That is one customer that's relayed that back that we have seen. 10% isn't shocking. It is very workload dependent. And the cost savings generally on ARM64 versus x86 is often in that 20, 25, 30, sometimes even higher than 30% on the hardware. So to me, which side are you picking? Is it cost savings or performance improvement? But like they're kind of two sides of the same coin. If you get
Got
one, you can go and spend more on hardware, right, to get the performance you need. But
Okay.
generally, cost savings sometimes of 30% with a performance boost of 10 or up to 20%.
Okay. Thank you. Well, so in addition to shipping product for other people to self-manage, you also have a hosted service, right? Crunchy
Yep.
Bridge. Um, are you running that on ARM64? And what's your experience been with that in terms of like the operationalization of it?
Yeah, it's generally been great. There early on, we were very careful as we started on x86, but we introduced ARM64 very, very kind of quickly. So you know, customers that came on in year one and a half, year one of the service, kind of after that point, were already on ARM64, which was much easier.
Okay.
We definitely proceeded carefully as we migrated customers and workloads from x86 to ARM64. Within Postgres, like it was unclear if the base backups and write ahead log that kind of powers everything within Postgres, like, can we replicate seamlessly from x86 over here to ARM64? That was a big kind of unknown of like, is this going to work? Are we going to break some stuff? We weren't 1,000% sure of that. And, at the time we proceeded carefully, did some thorough testing. What seems to be amazing is that does seem very compatible within Postgres. The biggest kind of surprising change is if you're on a different version of glibc, that's independent of x86 or ARM64. That's the bigger outlier of if those systems are going to be incompatible. But that made it very easy for us over time to migrate customers that were early on from x86 to ARM64 pretty seamlessly. So now I'd have to check if we're 100% of our fleet on ARM64. So it's hard for me to say, performance boost or gains because we were so early on there, or cost savings, because it's been our default early on, but
Right.
it's been generally a great experience. I'd hate to kind of consider going back, right? But that was one of those journeys that, hey, is migrating from x86 to ARM64 in a Postgres replication method compatible? And it seems the answer is yes. So if you're in that experience specific to Postgres, good news for you. You should have a easier migration journey than having to do so much legwork to figure that out yourself.
Well, Craig, thank you very much for joining me today. It's been a great pleasure talking to you, and I look forward to seeing you soon.
Yeah, thanks so
And
much for having me.
yeah, and to all our viewers, we look forward to seeing you on a future edition of the Ampere Developer Impact.